So as we said in our last lesson, similar polygons have the same shape and the same size. Different sizes. Same shape, different size. So what we know about similar polygons is two things. Their angles are congruent, that's why they're the same shape, but their sides are what we call in proportion. And those are the ratios that we talked about in the previous lesson. So we're going to be able to write proportions to solve for missing pieces. The scale factor we talked about last time is the comparison of the two shapes. So it's the ratio of the two shapes, of one shape to another. We should say one figure to another because they are the same shape. So we're going to look at some pictures, and it says each pair of polygons is similar. So that means the angles are congruent and the sides are going to be in proportion. So write and solve a proportion to find each missing side. So one of the things you're going to notice is some of these pictures aren't facing the same direction. For example, this one. Notice we've got this parallelogram with 12 and 8, and then this parallelogram with x and 3. Hopefully it's obvious that this one is not facing the same direction as this one. So if I were to turn this one around a little bit, the 3 would be on top and the x would be on the side. And then I can compare like sides to each other. So when they want us to write a proportion, we're going to use this scale factor. Let's take the two sides we know, for example, the 12 to 3. I'll write that down. That means my scale factor, when I simplify this, is 4 to 1. We're going to use that scale factor to write a proportion. So we'll say 4 to 1. We were going from left to right, the big picture to the little picture, and now we go 8 to the x. And you can either look at this to scale it and notice, oh, 4 times 2 is 8, 1 times 2 is 2, or we do our cross multiplying and to get 4x, 4 times x, and 8 times 1, find out that x equals 2. So we recognize that we had similar polygons, which meant the sides were in proportion. We had to turn the picture to make sure we were comparing the right sides, because if I had said 12 to x and 8 to 3, that would have been kind of weird, because you can see in the picture that the 3 should match up with the 12, so we just turned it. Letter B is similar because of the pictures are reflected. This one's upside down. So if you want to, you can turn this one right side up to compare it and see if we can get it right. Now, I'm going to notice that this angle has 2 arcs, and the angle between the 4.8 and the 8 had 3 arcs, and then the angle between the 4 and the 8 had 1 arc. So even though I reflected my triangle, notice how it's still not facing the same direction as this one. So you've got to be really careful. This one's flipped over. So I do know that the 10 goes with the 8. That's for sure. So 10 over 8 reduces to 5/4. That's my ratio. Now notice the 5. I think of it like a street. 5 is between the 1 arc and the 2 arcs. So I go to this picture. What's between the 1 arc and the 2 arcs? That's the 4. 5 to 4. That's my scale factor. So that means x between the 2 arcs and 3 arcs matches up with 4.8, which is between the 2 arcs and the 3 arcs. So I'm going to write this. 5 to 4 equals x to 4.8, because we had to sit and look at it to figure out which sides actually correspond to each other. Now you can solve this proportion without reducing your ratio, your scale factor. I just like to reduce it first because it gives me smaller numbers. So now I'm going to do 4 times x is 4x. And then 5 times 4.8. I'm going to grab my calculator because I don't know that in my head. 5 times 4.8 is, there we go, 24. And I found out that x was 6. My missing side right was 6. Okay? It's nice when the shapes face the same direction. Like look at letter C. See one arc, 2 arcs, 2 arcs. They're facing the same direction. So it's a little bit easier to set up your proportions. If they're not facing the same direction, you match them. You can flip it around. You can turn it to make everything match and then use your proportion from there. So right here, if I match everything up, 20 goes with 10.5. 29 goes with 14.5. And x goes with 10. Now these are all supposed to be in the same ratio. So it doesn't matter if you did 21 over 10.5 equals x over 10, or you could do 29 over 14.5 equals x over 10. We're still going to get the same answer. So whichever one of these you want to turn into your ratio. I'm just going to use the 21 over 10.5 just because it's there. And again, you can simplify this first if you want to, or you can just start multiplying. So 21 times 10 is 210 equals 10.5. Oops, I put the x in the wrong place. 21 times 10 is 210. 10.5 times x is 10.5x. And then we just grab calculator. Again, I'm using my Calc 84 on my cell phone. It's a really good TI-84 calculator. Does everything, almost everything your TI-84 does. So 210 divided by 10.5, x is 20. And I don't know about you, but that kind of makes sense because when I looked at these originally, I thought this ratio is 2 to 1. So it makes sense that it would be 20 to 10. That works. Okay, the next shape, we've got a quadrilateral. And if you look at the arc measures, everything matches up. So you can just go top to top, left to left, right to right. So you can pick any of these to make your scale factor. We could check and make sure they all match. For example, 22.4 over 14. That's my top to top. My left to left, 12.8 over 8. My right to right is 12 over 7.5. And then the bottom is the part I don't know yet. Now, if you're thinking, are those really in proportion? Well, we just grab our calculator, and I'll do 22.4 divided by 14. And I'm going to use my math button and turn that into just a reduced fraction. So that's 8/5. I'm going to check this one and see if it's really 8/5. You can use the fraction button, 12.8 over 8. Oh, see, that gave me 1.6, but I wanted it as a fraction. So I'm going to do math. See, it says change it to a fraction. Enter, enter. 8 over 5. So far, so good. 12 over 7.5. Make that a fraction. 8.5 or 8 over 5. So I think it's safe to say our scale factor from the big picture to the little picture is 8/5. And now I'm just going to cross multiply. 8 times x, and then 5 times 26 is 130. So 130 divided by 8 is 16.25. So we used our scale factor since we knew they were similar figures, and we wrote a proportion to solve for x. Now let's take a look at something a little bit different. We're going to investigate the effect of dimension changes on the area and volume of a solid. That'll all make sense in just a minute. Let's say we took this rectangular prism and I asked you to find the capital P. Remember that was perimeter of the base? Now I've shaded this side right here because I want that to be my base. So 8 and 6, if that's my base, 8 plus 6 is 14. and another 14, the perimeter would be 28. 8 plus 6 plus 8 plus 6. The area of my base, remember, length times width, 48. So far, so good. Now the lateral area. I think the formula for lateral area was perimeter times height. If you've got your formula sheet there, you can tell that. Well, I've calculated the perimeter. It was 28, which means the height of my prism, the distance between the bases, is 10. So my lateral area is 280 square whatever units. My total surface area, the formula for that one was pH plus 2b. So I already found my pH, that right here, that's 280, plus 2 of my bases. The area of my base was 48, capital B stands for area of the base. And then I start calculating. 280 plus 2 times 48. That's 376 for my total surface area. And then volume. Technically, the formula for volume is area of the base times the height. But in a rectangular prism, that's just like length times width times height. So 48 times 10 is 480. Okay, so that was good practice, good review of a previous chapter. Now we're going to do something with all of this. So keep this handy. And we're going to go to the next page, and it says to do something. It says now double each side of the rectangular prism, and fill in the chart. Okay. So we're going to take our original prism was, I'm going to keep it there so I can see it. I know you can't see it, it's off the screen. My original prism was 6, 8, 10. So my new prism, just so I have a visual, is 12, 16, 20. So let's go through the same process, find the perimeter, area of the base, and all of these things. All right, so this was my base. So if I do 16 times 2 plus 12 times 2, I get 56 for my new perimeter. Area of my base is 12 times 16. That's 192. Lateral area, remember pH, perimeter times the height, so 56 times 20, 1,120. And my total surface area is the number I just found plus 2 capital B's, 2 area of the bases. So I'm going to take my 1,120 plus 2 times 192, which is 1,504. The volume was the area of the base times the height. So area of my base was 192, the height was 20. 192 times 20, 3,840. All right, now I'm going to go back to my other paper and fill in the original data, which I had here. Perimeter was 28, capital B is 48, 280, 376, 480. So I just filled this information in from the previous page. Now, let's see what happened. If I doubled every dimension of my rectangular prism, let's see what happened. So what's the ratio of the perimeters? So since we doubled the side lengths, the similarity ratio, or the scale factor, is 2 to 1. The new one is 2, the old one was 1. So this was new to old, or original. So what's the ratio of the perimeters? Well, 56 over 28. If you need to use a calculator, you can. That's 2 to 1. Let's check the ratio of the areas. 192 over 48. So if I put that in my calculator, I'll use the fraction button, alpha y equals. I can't imagine you don't know that, but if you don't, it's alpha y equals, oops, allows you to just type in a fraction. That's 4. So I'm going to write that as 4 to 1. Interesting. The lateral areas, 1120 to 280. 120 over 280, also 4. I find that very interesting. So if you had to guess right now what the surface areas might be, any guesses? Let's check your conjecture and see if you're right. 1,504 over 376, also 4. Alrighty, so now let's check the volumes and see what happens there. We'll take 3,840 over 408. 480. Is it going to be 4? What do you think? Or is it going to be 8? All right, so let's take a look at these and see if we can figure something out. The perimeters, if the scale factor was 2 to 1, notice the perimeter had the exact same scale factor. So the perimeters and the scale factor were the same thing. Now take a look at all of the areas. Anything that had to do with an area was 4 to 1. That's interesting. Think about it. If I take a figure, I'll just take a square, or I'll say it's a rectangle, 3 by 4. If I multiply this one times 2, and I multiply that one times 2, when I find the area, it's like I'm multiplying by 4 because this was times 2 and that was times 2. So the area actually got multiplied by 4, or 2 to the second power. Then we look at the volumes. So take a look at the volume of a shape. Let's say I just took a little cube and I made all these, it was a 3 by 3 cube. If I multiply each one times 2, and then I go to find the volume, well, I have an extra 2 times 2 times 2, which is actually an extra 8, or you could think of that as 2 to the third power, because its volume, it had 3 of the 2's that we're going to multiply by. So there's relationships there. If the ratios of the lengths is A to B, that's any linear measure. So perimeter, or in some other problems, we're going to have like a height or a base or a slant height. Any linear measure has the same ratio as the lengths. The areas, any area of a base, lateral area, total surface area, has a ratio of A squared to B squared. We square the ratios. So think about it, area is in square units. That always helps me to remember that the ratios are A squared to B squared. And then the volumes, A cubed to B cubed. Because we have, remember, it's 3-dimensional, so we did a times 2 3 times. So that was 2 to the third power. And again, volumes, just like area is units squared, volume is units cubed, and so their ratios are cubed. So you really have to think through these and think about which one you're using for which particular question. So now we're going to practice. If the ratio of the heights of two similar solids is 3 to 4, so notice heights, that's a linear measure. That's the scale factor, is 3 to 4. What's the ratio of the surface areas? Well, if the scale factor is 3 to 4. The areas are 3 squared to 4 squared, which is 9 to 16. Because they're areas, it's a squared to b squared. What's the ratio of the volumes? Remember, the volumes are a cubed to b cubed, so go back to your scale factor. 3 cubed to 4 cubed. So you always go back to your scale factor and you square things and cube things. Now, number 6. The ratio of the surface areas is 10 to 49. So they're giving us the a squared to b squared. We need the scale factor. Whenever they give you something other than the scale factor, you go back to the scale factor. So if this is a squared to b squared is 100 over 49, you just take the square root to get back to the scale factor, and that would be 10 to 7. Now find the ratio of the volumes. You use the scale factor to do 10 to the third over 7 to the third, which is 1,000 over 343. Make sure you always go back to the scale factor. And this last one, we gave you the ratio of the volumes. So remember, this is a cubed to b cubed when they give you the volume ratio. So we've got to go back to the scale factor first. Now, if you don't know what the cube root of 64 is, grab your calculator, go to math, and there is a cube root button right there on number 4. And you could take the cube root of 64 if you weren't sure what it was. So the cube root of 64 is 4. And the cube root, we could do it again, math, number 4. Cube root of 27 is 3. So if you didn't know what the cube root was, you can use your calculator. So the scale factor of these two figures was 4 to 3. What would be the area ratio? Remember, the area ratio is a squared to b squared. So 16 to 9. So in all of these problems, the linear measures have the same as the scale factor. Any area ratio is a squared to b squared. Any volume ratio is a cubed to b cubed. And no matter which piece of information you are given, go to the scale factor first and then answer the other question. So you want to be really careful with those.